Hey everyone, welcome back to my channel, where we dive into the world of coding and solve some of the toughest problems out there. Today, we're going to tackle a medium-level problem from LeetCode, called Earliest Finish Time for Land and Water Rides 2. This problem requires us to find the earliest possible finish time for a tourist who wants to take both land and water rides. So, let's get started and see how we can solve this problem. The problem gives us 4 vectors: land start time, land duration, water start time, and water duration. We need to find the minimum finish time for the tourist, considering all possible combinations of land and water rides. This is a classic problem of finding the minimum finish time, given the start times and durations of the rides. So, what's the core insight here? Well, think of it like this. Imagine you're at an amusement park, and you want to ride both the roller coaster and the Ferris wheel. You can start with either ride, and then take the other one after you're done with the first one. The key is to figure out the earliest possible finish time, considering the start time of each ride and the duration of the previous ride. This is a perfect example of a problem where we need to consider all possible combinations of events to find the optimal solution. Now, let's walk through the solution step by step. We'll start by initializing the minimum finish time to a large value. Then, we'll iterate over each land ride and each water ride, considering all possible combinations of rides. For each combination, we'll calculate the finish time assuming the land ride is started first, and update the minimum finish time if necessary. We'll do the same thing assuming the water ride is started first by considering all possible combinations. We can find the earliest possible finish time for the tourist. Now, let's take a look at the code. We start by initializing the minimum finish time to a large value, using the int_max constant. Then, we have 2 nested loops, one for the land rides and one for the water rides. Inside the loops, we calculate the finish time assuming the land ride is started first, using the max function to find the later start time between the land ride and the water ride. We add the duration of the water ride to this time, and update the minimum finish time if necessary. We do the same thing assuming the water ride is started first by using the max function. We ensure that we're considering the correct start time for each ride. Now, let's talk about the time and space complexity of this solution. The time complexity is O(n)m, where n is the number of land rides and m is the number of water rides. This is because we iterate over each land ride and each water ride once. The space complexity is O(1), as we only use a constant amount of space to store the minimum finish time in the iteration variables. This is a very efficient solution, considering the number of combinations we need to consider. And that's it for today's problem. I hope you guys enjoyed this solution and learned something new. Don't forget to like the video, subscribe, and comment your approach below. If you have any questions or want to discuss further, please let me know in the comments. Thanks for watching, and I'll see you in the next video.